Afternoon class, so it's Sir Capistrano again. So we're here for another lesson for our Physics 1.1 and Physics 1. Wherein for today, we'll be talking about projectile motion. So by projectile motion, this is one of the most familiar motion that we actually encounter every day. So, halimbawa, when we are tossing a coin, uh, towards a certain direction, kapag nag-serve ka ng bola sa volleyball or nag-hagis ka ng bola sa basketball, ganyan, or bola ng basketball, the motion itself that is followed by the object that you thrown is actually called a projectile motion. And by projectile, by the word projectile itself, it is actually any body that is given an initial velocity and then follows a path determined entirely by the effects of gravitational acceleration and air resistance. So, himayin lang natin yon. It is any body. Meaning to say, it can be an object, a particle, or kung ano man that has mass with an initial velocity. So, yun yung mga, ito pa yung isang kailangan nating tingnan. We have there a V naught. So, as you may notice here, there is no subscript such as x or y with this initial velocity. Uh, and we'll see later on why is that. And it is affected by gravitational acceleration, just like our falling body earlier in this course or before this video. And lastly, we have their air resistance, which is actually a force, a frictional force. So, it is actually related to one of our lessons earlier, yung sinabi ko nga kanina, yung ating free-falling body because of that gravitational acceleration and resistance. And just like our free body, or our, not free body, just like our free-falling body, we can actually have an idealized projectile or projectile motion. So by idealized, just like our free falling body, we will neglect the frictional force. So hindi natin i-consider yung air resistance na na-encounter nung ating tinatawag na projectile. And for projectile motion, our projectile actually follows a certain path na tinatawag natin. So, let's say this is our y-axis, and we have here our x-axis. Kung halimbawa, yung ating body ay nag-start dito sa ating origin, which is, kung sa coordinate plane natin, this is our 0, 0. If we have a projectile motion, or we have a projectile that is given an initial velocity, say this is the path that is followed by our projectile, say we have here our v naught, our projectile will actually follow a certain path wherein ang mangyayari, it will follow some kind of path na parang halos parabola yung itsura na ganyan ang itsura. And this path is actually what we call the trajectory. Okay? And in that trajectory, considering that we don't have any frictional force that is opposing the movement of our projectile, pwede natin actually i-quantify yung ating yung movement ng ating projectile via our x component. Pwede natin siyang tingnan dito sa x-axis and also dito sa ating y-axis. Medyo napahaba yata yung ano ko. But in any case, uh, since we are talking about velocity, we'll be remiss if we don't mention acceleration. And for this type of acceleration, for what we call idealized projectile, for an idealized projectile, meaning we don't have our frictional force, we will actually have two quantities of acceleration. Wherein our acceleration is actually, we will have a vector quantity of our acceleration that is actually having the components of x and acceleration component of y. And these two, under our idealized projectile, actually have specific values. For the x component of our acceleration, we will have here 0 meters per second. And for our y, this is actually just equal to the negative g. Or by negative g, it is the acceleration due to gravity, which is equal to, or g is equal to 9.8 meters per second square. So, maaaring yung iba sa inyo nagtataka, Sir, why zero? Bakit zero yung ating acceleration in x? So, in an idealized projectile, since walang kokontra dun sa movement nung ating projectile, mapa x-axis or y-axis man yan, uh, walang force na kokontra dun sa movement ng ating projectile papuntang x-axis. That is why we will not have any deceleration or acceleration via on the movement of our projectile on our x-axis. And para naman dun sa y-axis natin, since it is moving upwards then downwards, we may say that we have there our movement, or we will have there's a component that follows what we call the free falling motion. So, or free fall motion. So, in that, sa ating idealized projectile, dahil nga constant yung ating acceleration, as you may see here, constant na zero siya, at constant para dun sa x, zero siya para dun sa acceleration sa x, at we have a value of negative g for acceleration in y. We can actually use our equations na ginamit na natin dun sa ating motion along the straight line, and also our motion regarding free fall. So basically, we can actually quantify certain values of our vectors here. So as you can see here, kung meron kang v-naught dito, bakit nga ba v-naught lang yan, walang x or walang y? Kapag pag-uusapan natin yan, kapag ibinalik natin yung ating understanding sa ating vectors, as you may have remembered, magkakaroon tayo dito. If this is a vector quantity, we will have here two components. So meaning to say, having this triangle and this angle, we actually have here, we can actually have here our v naught x, which is the x component of our vector v naught, and we will have here a vector y. Sorry, medyo hindi kita na. Basically, we have here a v naught y. And uh, looking into this, pwede na natin actually ma-quantify kung ano ba yung magiging Vx natin, or yung magiging final na, or yung resultant vector natin ng ating movement. Kung halimbawa, yan nga yung V0, pero you want to study kung ano yung, or you want to compute whether kung ano yung Vx dito, pwede natin yan ma-quantify later on using the values of our x components and y components of our vector here. So, also, we can actually look for the values of x, or the position of our projectile based on our x-axis, and the position of our projectile based on our y-axis. Therefore, uh, not just vx, just v, sorry. And which is actually, kung aalalahanin nyo, kapag meron tayong vector quantities, is just the square root of the vector quantities Vx square plus our Vxy. So, ganyan natin siya ititreat later on. So, ano nga ba yung mga formulas na yan? So, for our Vx, dito muna natin simulan. Our Vx is actually equal to our V naught x. Why? Bakit yung Vx ay equal lang sa ating V naught x? Because of our acceleration. Since our acceleration is constant, which is 0, kung ibabalik natin actually dun sa ating equation 5 nga ba, or equation 6, our Vx is actually just equal to our V naught x plus our acceleration of x times our time. And as you may have remembered, or as I stated earlier, for our x component, our acceleration is actually equal to 0, meaning to say this will be 0, and we will have this x component of our velocity. Also, talking about the x component or the position of, as you may have remembered, we have the formula, equation 9, which says that x is just equal to the initial position, which is x naught, plus our v naught, or our initial velocity in x, multiplied to our time, plus the 1/2 of our acceleration in x, uh, multiplied to time square. And dahil zero nga yung ating acceleration, meaning to say, itong buong quantity na to actually ay magiging zero lang din. So, we will be left with x is equal to x naught plus v naught x times time. So, that is our x components of of our projectile motion. So, how about the y? So, same scenario. We will still be using equation 6, this one. So, for this time, y na yung magiging subscripts natin. So, meaning to say, our Vy, or our velocity in terms of the y coordinate or y axis will be equal to V naught y plus the acceleration in y times t. And since our acceleration is constant, as you may have remembered, we have here our negative g. The velocity in the y component of our resultant velocity will actually be equal to our v naught y minus uh, g times time. And for our y position, ganun lang din, ano? We will be using equation 9, but instead of x, lahat ng x dyan, papalitan lang ng y, and our acceleration in y will be negative g, meaning to say our y there will be our initial y component or initial y position plus our v naught y times our time minus 1/2 of our g. Bakit siya minus na imbes na plus? Because we have their negative g and we'll have their t square. So, yan yung uh, mga formulas natin. Okay? Pero kung iisipin nyo, kung bibigyan tayo ngayon ng problem at sasabihin sa atin na compute for the position and compute for the resultant velocity, hindi natin actually diretso mako-compute yun. Kasi halimbawa, ang binigay lang sa atin ay, ang given lamang sa atin ay yung ating initial velocity. Wherein it is an initial velocity that is a vector. Hindi pa natin alam kung ano yung y component ng vector na yan at hindi rin natin alam kung ano yung x component ng vector na yan. So, paano natin yung gagawin? So, basically, we need to quantify for the we need to quantify the value of our x components and y components para makuha natin yung ating mula, i-compute natin yung ating x component and y components from that v naught. So, paano yan gagawin? So, tingnan lang natin dito. So, i-rewrite ko lang ulit yung mga formula. So, basically, for Vx or V component of x, or the velocity of in x will be equal to our initial velocity due to constant acceleration, which is equal to 0. Our Vy will be equal to our initial initial velocity in y minus our acceleration due to gravity times time. Also, we will have for the x component will be, or the x component for position will be x naught plus our v naught x times t. And for our y, that will be our initial position, y naught, plus our initial velocity in y times time, and minus the 1/2 of acceleration due to gravity times time square. So, yan yung mga formulas na nakuha natin kanina. So, paano natin to i-compute na ang given lang sa atin ay yung ating V naught. So, ganito siya. Okay? So, for example, we have here an object, say a particle or kung ano man, that is affected by gravity na meron tayong initial vector quantity na pa ganyan. And may movement siya ganyan and so on. Pababa ulit. Okay. So this will be our V naught. Okay. So ang kailangan nating ma-compute class ay yung ating we need to compute for our Vx, our V naught x and V naught y. So, kung halimbawa, gumawa tayo actually ng isang triangle dun sa head to tail ulit na ginagawa natin dati sa vector. This side actually it will be our vector or initial vector component for our y. Kasi bakit siya y? Kasi pataas siya. Okay? And also, we have here a vector component which is v naught x. And as you may have remembered dun sa ating Sokatoa, okay? So if we have this as our horizontal plane, and we have here an angle, say we have here our alpha, or our initial angle, dyan sa part na yan, pwede natin actually gamitin yung ating SOHCAHTOA na inaral natin dati sa ating trigonometry. So by SOHCAHTOA, So means that sine, opposite, hypotenuse. And we have there our cosine, adjacent, hypotenuse. And we have here our tangent, opposite, adjacent. So, paano natin to gagawin? I mean, saan natin to gagawin? Or saan natin to gagamitin? So basically, we have here, note lang natin. We have here three parts of our right triangle. As you can see here, this is actually a right triangle. And we have here our angle. So, ang ibig lang sabihin ng opposite, hypotenuse, or opposite, ayun yung side na opposite sa ating, or katapat ng ating angle na hindi hypotenuse. May hypotenuse, it is the longest side of our triangle. Meaning to say, that our V naught y is actually our opposite. And by adjacent, it just means that if your reference is this angle, it is the side that is actually yung katabi, adjacent dun sa ating angle na hindi yung hypotenuse. So meaning to say, our Vx here, or this Vx is actually our A, and this will be our hypotenuse. So, ano naman na, kung meron ka na yan, sir, ang ibig lang sabihin niyan, if we are to compute for the opposite side or that vector of opposite side, we just need to use our sine and our hypotenuse. Meaning to say, you just need to multiply your hypotenuse to the sine, ay, our, tawag dito, our opposite is just equal to our hypotenuse multiplied to the sine of our angle. So, yun lang ang ibig sabihin niyan. So for ka, or since gusto nating makuha yung A, so, or yung ating adjacent will be just equal to our hypotenuse multiplied to the sine of our angle. So, ano ba yung angle natin? Our angle will be that alpha. Alright? So, ano ba yung opposite natin? Opposite natin is actually our V naught Y. What is our H? Our H will be our V naught. So, basically, pwede na nating makompute yung ating X and Y components ng ating mga values dito. So, in that, we will have this equations. So, we're in our V naught X will actually be equal to our V naught X will be equal to our hypotenuse, which is our V naught, multiplied to the sine of our theta, which is alpha, or the initial angle that nung projectile natin. And for the y, or the y component of our velocity, or v naught y component of our velocity, that will be equal to our h, which is our v naught, multiplied to the, baliktad yata, cosine pala dapat ito. Sorry. So that this will be cosine. And for y, that will be sine alpha. Okay? So, paano ulit nangyari yun? So, para dito sa v naught x, this will be our adjacent. This will be our hypotenuse. At ito yung ating cosine. And for our v naught y, this will be our opposite. This will be our hypotenuse. And we have here our sine. Okay? So, andyan po ang ating SOHCAHTOA. So, basically, hindi naman na kailangan tandaan yung SOHCAHTOA, but you need to account for this formulas. So, basically, kapag kukunin na natin yung ating Vx, or Vx, gamitin natin ulit yung blue. Okay. So, we will have here, our Vx actually is equal to V naught x, meaning to say, we have there our V naught multiplied to the cosine of the initial angle, which is alpha naught. And for our Vy, V naught y, or Vy lang pala, not V naught y, our Vy is actually equal to our V naught y. So, meaning to say, that will be V naught times the sine of the initial angle minus the acceleration due to gravity, gt, times time. And how about the positions? So, for the positions, dito sa x muna, so that will be equal to our x naught, right? Plus v naught x. So, v naught x, ito po yun. So, we will have here v naught cosine of our initial angle multiplied to t. So, lagyan natin ang parenthesis para hindi tayo malito. And for y, or the final position, that will be equal to our y naught plus our v naught y multiplied to, oh, hindi ko na account for yung v naught y. So, v naught y is actually equal to V naught times the sine of R alpha multiplied to T minus the 1/2 of the acceleration due to gravity times our T square. So basically, we have here another set of our formulas or equations. So, inote lang natin, ito yung mga formulas natin. So, let's note that this is our equation 11. Ay, 12 na pala tayo. Equation 12, we have here equation 13, and we have here equation 14, and lastly, we have here our equation 15. So, those are our equations. Okay? That will be used for this motion. So we have here the formulas for computing yung ating mga vector quantities in terms pag pinag-uusapan na natin ang ating projectiles. And in that, pwede na tayong mag-solve ng problems. Pwede rin nating i-check na kung ano yung. Pero minsan class, gagamitin natin yung itong mga concepts na to para ma-compute din yung ating angle. So, ayun. For that, you will be using again the tangent wherein you need to account for the x and y component to compute for the tangent. Alright? So, let's have an example. So, I have here an example where it says here that a batter hits a ball, it hits a baseball, so it leaves the bat at the speed of V naught is equal to 37.0 meters per second at an angle of alpha naught, which is equal to 53.1. Find the position of the ball and its velocity. It just means magnitude and direction at time is equal to 2 seconds. And also, we need to find the time when the ball reaches the highest point of its flight and its height at this time. And also, we need to find the horizontal range, or that is the horizontal distance from the starting point where the ball hits the ground. Okay? So, kung sasabihin natin na ano na lang, magkaroon tayo ng konting discretion. So, kung ito-drawing natin to, let's just say that the bat is within the same level as our ground. So, para hindi ma-complicate yung problem natin. So, we have here our y-axis. We also have here our x-axis. So, ang sabi nun sa problem, if we set that the bat is our origin, or that is our starting point of the projectile, kung dito siya nag-start, uh, sabi ng problem, we have here an initial velocity which is equal to 37.0 meters per second. Also, we have here an initial angle which is alpha is equal to 53.1 degrees. So, kung drawing rin natin yung trajectory. So, ang trajectory natin ay magiging ganito yung itsura. Medyo i-allow nyo na yung hindi pagiging perfect, parabola ko. So, basically, ito yung magiging itsura niya. Let's first remove this x. Lipat lang natin siya. Kasi magkakaroon tayo ng problema. So, we have here three parts of the problem. So, to illustrate the first part of the problem, ang sabi niya, we need to get the position and the velocity of the ball at 2 seconds. So, if we say that this part is our t is equal to 2.00 seconds, ang kailangan nating makuha class for this problem or this part of the problem, we need to compute for this V. Okay? So, meaning to say this, mula ron sa V naught, syempre magbabago yung velocity niya when it reach or when we reach 2 seconds. And also, we also need to measure or to compute for the value of Y, okay, for the position. And also, we need to compute for the value of X. So, bakit ko dyan nilagay yung ano, bali, sukat lang yan, horizontal distance from the y-axis towards the ball, that is our x, and the height from uh, x-axis towards that ball, that is equal to our y. So for the second part of the problem, we need to compute for the height. So yun yung kailangan natin ma-compute. So bali itong portion na to, kung ito yung highest point niya, we just need to compute for the height kasi ito yung part na yung vector natin ay ano na, ay diretso. We need to compute for the height and the, tama ba? Find the time and its height. So, we need also to compute for the time. So, that is for the second part of the problem. Also, we need to compute for the R or the distance and the time. Tama ba? Find the horizontal range. So, mula rito sa origin, pantay. We just need to compute for the R, yung haba na yan. Okay? So, and also we need to compute for the time kasi hindi natin din alam kung anong time yun. So, we have here time 1, time 2, and this will be our V2. Okay? Basically, meron tayong tatlong velocities na kailangan i-consider. Velocity at this second point, velocity at the highest point, and velocity as it lands on the ground. Okay, so mahaba-habang computation ito. Alright, so simulan natin dun sa ating A. So let me just snip this. So, para kung sakaling kailangan natin siyang i-copy, copy natin siya later on. Okay, so for part A. So for part A, we need to compute for X, we need to compute for Y, and we need to compute for V. Okay? So, some considerations. So, for X, gagamitin natin yung formula natin kanina, wherein we have there our X is actually just equal to our V naught, V naught X times T, wherein our V naught X will be equal to, bakit V naught X na lang yung ginawa ko? Kasi ang origin natin or initial position natin ay X. So, pakita ko na lang din. Para ano. So, lagay lang natin mga given natin. So, we have here an initial position of X which is equal to 0. We have initial position of Y which is equal to 0 also. And we have here our initial velocity which is 37.0 meters per second. And also, we have an alpha or an angle that is actually equal to 53.1 degrees. So, yan yung mga gagamitin natin. And for this part of the problem, our time here is equal to 2.00 seconds. So for the x, kung babalikan natin yung formula, for the x component of this vector or projectile vector, our x is actually equal to our x naught plus our v naught x. V naught x times time. Bakit wala yung acceleration? Kasi 0 na siya kanina. So basically, sabi natin dito, 0 yung ating x. So, which means yan. And that also means that our x is just equal to v naught x times time. So, ang V naught X natin, our V naught X is equal to our V naught times the cosine of our alpha, which is actually equal to 37.0 meters per second that is multiplied to our cosine of, kalimutan ko pala yung time. Nandiyan din yung time. Cosine of 53.1 times time, which is 2.00 seconds. And kapag kinumpute nyo to, sige nga, try nyo muna i-compute. Okay? So, upon computation, this will be actually 44.4 meters. Okay? And for the y component, our y component, apply ko na rin na kasi yung y naught natin ay 0, so hindi ko na lang siya ilagay. Our y naught is actually equal to v naught y times time minus the 1/2 of gravity, or 1/2 of acceleration due to gravity, and we have here our time square. So this will be equal to our v naught y. So our v naught y is actually uh, v naught sine theta, ay not theta, alpha, multiplied to time, which is 2 seconds later on, minus 1/2 of gravity times. So that will be uh, 37.0 meters per second multiplied to sine of 53.1 degrees times 2 seconds, also that will be also multiplied to eh, minus 1/2 of 9.8 meters per second times 2 square, or 2.00 seconds square. So basically, kung i-compute nyo siya, nga, paki-compute muna. Okay? So this will be actually 39.6 meters. So, ibig sabihin lang, class, yung ano natin, yung ball, actually ay galing magiging, nag-travel na siya papunta ng horizontally ng 44.4 meters, and its height, yung height niya will be 39.6 meters. So, ganyan yung magiging itsura nung sa position ng ating bola. Okay? Alright. So, for the next part of the problem, wait lang, lagay lang natin siya doon. Okay, long slide naman. May na-skip tayo. Kaya second class. Okay? So, for the next part of part A na nga siya, may next part pa siya. We need to compute for the velocity of that number there, or yung vector natin dyan. So, anong gagawin natin dito? We just need to account or compute for the Vx nung sa area, sa part na yan, and we need to square that plus our Vy square. So, para makuha natin yung resultant natin dyan. So what we can do here is compute for uh, the Vx and the Vy. So for the Vx, sabi natin kanina, this is just equal to our V naught x. So for our V naught x, V naught x is actually just equal to our V naught multiplied by cosine, cosine alpha. Okay? So we will have here 37.0 meters per second. We just need to multiply that to cosine 53.1, and upon computation this will be 22.2 meters per second. And for Vy, same lang yung gagawin natin. You just need to use the formula. So pwede nyo i-pause yung video saglit para makapag-compute kayo. So our Vy will actually be equal to our V naught y minus our acceleration due to gravity times time. So what will happen here is we will have V naught y. V naught y is just V naught sine alpha minus our acceleration due to gravity times time. So this will be equal to our 37.0 meters per second times the sine of 53.1 degrees minus 9.8 meters per second square times our time, which is 2.00 seconds. So we will have here 10 meters per second. Okay? So that is our Vx and Vy. So i-apply na lang natin siya ron sa ating vector, wherein we will have here our V will be equal to our 22.2 meters per second. You just need to square that. Then plus 10.00 meters per second. And you need to square that. So upon squaring, then getting the roots, ano kaya magiging sagot? So we will have there 24.4 meters per second. Okay, so how about the angle? Anong angle, sir? Ibig sabihin ko lang, class, kapag kasi andito na tayo sa area na to, magkakaroon ng sariling angle yung area na yan wherein you will have there your alpha 1 or yung first angle nyo sa measurement nyo. So for that, babalik lang kayo dun sa ginagawa natin dati na arctan. Gagamitin lang natin yung tan raised to negative 1 or tan raised to negative 1 nung y component divided by our x component. So para makuha nyo yung inyong angle. So basically, that will be your angle will actually be equal to arctan or tan raised to negative 1 of your y component, which is 10 meters per second, all over our x, which is 24.4 meters per second. And kung i-compute nyo siya, so check nyo sa calculator nyo, this angle is actually 24.2 degrees. Meaning to say, our at time is equal to 2.00 seconds, we have there an x that is actually equal to 44.4. Ibig sabihin, it has traveled horizontally for 44.4 meters. And also, we have there a y that is 39.6 meters. Okay? So, meaning to say, it has a height of 39.6 meters and it has a bearing or a velocity that is actually equal to 24.4 meters per second. So, ito yun. uh, then 24.2 degrees north, eh, sorry, north of east. So, yan yung mga answers natin para dun sa part A. So, para sa part B naman, we need to get into the highest point naman. Doon naman tayo sa highest point ng ating projectile. And we need to check for ano bang gagawin natin? The time, ayun, time and height. Okay, checking lang class kung recording pa rin ako. Alright. And let's do that. So, at the highest point, just like our dito, just like our free falling body, this is for letter B. Gusto ko lang sabihin na since highest point na siya, as you may have remembered in our free falling body, our velocity of y will be equal to 0 because it is the highest. Okay? So in that, we can actually, with that value, we can actually compute for the time it happens and also kung ano yung magiging height niya mismo. And for that notion or for that scenario, what we can do actually is account for the Vy. So for the Vy, as you may have remembered in this discussion, our Vy here in projectile motion will be actually equal to our V naught y minus our G T or acceleration due to gravity 1 is actually uh, is is actually equal to 0. Kasi sabi nga natin, ang Vy natin ay 0. So working on that, we will have here a V naught minus GT1 is actually equal to 0. And upon algebraic manipulation, we can actually have here a GT1 or time 1 or acceleration due to gravity times 1 uh, is equal to our V naught. Okay? V naught y. So in here, kapag dinivide natin yung both sides of the equation with g, we will have here the quantity time kasi magka-cancel out yan and that this will be equal to our V naught y over g. And as you can see here, yun yung kailangan natin. We need to get that time. Okay? So, in that, uh, we'll have here our V naught y over g. And as you may have remembered, our v naught y is actually equal to our v naught times the sine of our alpha over g. So this will be v naught natin is 37.0 meters per second. And that will be multiplied to the sine of 53.1 degrees all over 9.8 meters per second square. In that, compute. So we'll have there, this is 29 something to 29 divided by 9.8. So we will have here 3.02 seconds. Okay? So that will be our time. So ngayong meron na tayong time, pwede na nating makompute yung height or yung highest point. So basically, our highest point h is just equal to our y. So, paano natin ko-compute yung y? So, basically, y is just our y naught, which is just 0, so hindi na natin isusulat, plus our v naught y, or the initial velocity in y, times t1 minus the 1/2 of our acceleration due to gravity times time 1 square. Okay? So, this is actually just equal to our 37.0 meters per second. Right? multiplied to, ano, hindi lang pala yan. Sorry. So, ayun, this will be equal to our V naught twice, which is actually just V naught sine alpha times our time 1 minus the 1/2 of gravity times time square. Okay? So, compute lang natin. So, that will be 37.0 meters multiplied to the sine of 53.1 degrees times time, which is, ang sabi natin, 3.02 seconds minus the 1/2 of 9.8 meters per second square times 3.02, hindi na nagkasya, square, or 3.02 seconds square. And simplifying this, we will have here 44.7 meters. Meaning to say, our highest point is 44.7 during 3.02 seconds of the flight of the ball. Alright? So, for the last part, ito na yung class yung medyo katulad nung ginawa natin last time dun sa ating free fall. Ano? So, ano bang ginawa natin dun sa free fall natin? So, dun sa free fall na ginawa natin, we actually used our quadratic equation para ma-compute natin yung time para makita kung ano, yung sa terms of distance. And for this, halos ganito rin yun. So, bali kasi ang nangyayari, kailangan nating malaman kung anong ano yung distance. Or meaning to say, we need to get the distance kung saan or yung time. Gusto nating makuha yung time na to nung umabot na sa lupa yung bola. So, bakit natin gustong malaman yung time na umabot na yung bola sa lupa? Because we need to compute for this distance. And as you may have remembered, our x is actually equal to our x naught, which is actually 0. So, ito po ba yan lagi sinusulat? Times the v naught of x times time. And because of that time is actually our t2. So, kailangan muna nating makompute yung time na yan bago natin makocompute yung x. So, kailan ba saan pa natin pwedeng makuha yung time? Pwede natin actually makuha yung time dun sa pagko-compute natin ng y component. By y component, this is just equal to our y naught, and since our y naught is 0, hindi na natin siya ilalagay, uh, times y naught is v naught y times the time. For this time, we have the second time here minus the 1/2 of our gravity times time square. So, yan yung ano natin, yung tawag dito, yung way natin para makuha yung time. Pero paano? So, basically, if you account for the time na nasa baba na yung bola, ang ibig lang sabihin niyang class, yung y natin is actually 0 na. So, dalawang beses na nagkaroon tayo na yung y natin or yung height ng bola natin ay nasa 0. That is from the origin and that dito sa dulo. So, ang pwede natin gawin dito class ay manipulate natin ito So we will have here 0 is equal to V naught y t2 minus 1 half of the acceleration due to gravity uh, times time 2 square. So, in here class, pwede na nating i-manipulate itong equation natin para mapalabas natin yung mga t natin. So, wherein we can manipulate then this in such a way that we will have here t2 mul- is or multiplied to our v naught y minus 1 half of our g times t2. So, kung gagamitin natin, gagamit tayo ng quadratic equation for this part, makukompute natin actually yung dalawang roots. So, uh, we will have here t2 that is equal to 0, and ito yung nandito sa part na to. So, yun yung unang t2 natin. And we will have here, it nga lang, parang may mali ako ginagawa. Hmm, mali nga. Alright. So, what will happen here is we will have, kung i-transform natin siya into quadratic equation. So, we will have here 1 half g2 square minus our v naught y t2 is equal to 0. Which actually, magkakaroon tayo dito ng pwede natin itong masolve dun sa quadratic equation na ginamit natin last time. And what will happen here is we will have two roots, wherein our roots will actually be 0, yung isa. Okay? And we will have here at E2 that is actually equal to 6.04 seconds. So, yan yung dalawa nating makukuha dyan. And in that, we can actually now compute for the range ng tinatawag natin or yung horizontal range natin. So, sabi ko nga kanina, itong 0 na to, ito yung part ng sa simula, yung sa initial, and that's this T2 na nandito sa dulo, or 6 seconds nung nandito na siya sa dulo. So, then we can compute for this X, okay? So, our X is actually equal to our R, the horizontal range, which is actually equal to our V naught times T2, which is actually equal, V naught X pala, which is actually equal to our V naught multiplied to the cosine of our alpha times T2. So, we'll have here 37.0 meters per second multiplied to the cosine of alpha, which is 53.1 degrees, multiplied to time, which is 0.64 seconds. And we will have here 134 meters. Meaning to say, the range of the ball, or the horizontal range of the ball will be 134 meters. So, in that, we have the horizontal distance from the starting point to where the ball hits the ground. Right? And that will be all for this video. So thank you very much for uh, watching this video. Bye.